Some of you thought that some of the videos on how to solve these types of problems were a little bit too fast, and so I am going to make a painfully slow video showing every little detail about how to do this problem in a very organized and process-oriented way. Now, if you think it's too slow, you can watch the original video, or you could just fast forward or skip parts of this video when you get to a part that you totally understand. Move on, okay? So, you get a problem like this with a sine, cosine, or tangent equal to some value, and then they give you a domain which should generate all the solutions, or should give a limit to the solutions that you find for this, because if they don't give you a domain, then basically there's an infinite number of solutions, which I'm going to show you in a second, okay? So the first thing you should do when you get a problem like this is you should make sure that you have the sine, cosine, or tangent on the left, and then you have a number on the right, and you don't have any numbers like here or anything like that that you need to move over there doing algebra, okay? I chose this problem because it has a very complex inside to the sine, and I think that's the hardest part. The algebra part on the outside, I think that most people deal with okay. So, let's get started. First thing you're going to do is you're going to make a little table. And the table is going to have 3 columns. The first column is going to be x. The second column is going to correspond to the inside of here. So I'm going to put 4 times x minus pi over 4. And then I am going to also call this column, let's call it z. Okay. I don't want to call it y because a lot of times we use y for the function name, so we'll call this expression here z. And then in the last column we'll put the sine of 4 times x minus pi over 4. We could also say sine of z because z is the same thing as that, right? Rewrite this, kind of messy. Okay. And of course, we want the angles, these angles, z angles, which give us a sine of 0. And the first part you're going to do is you're going to like draw a unit circle, and you're going to figure out what are the angles which give you a sine of 0, and we know that that's this triangle here and this triangle here, so that's basically 0 degrees and 180 degrees, 0 and pi, 0 and pi. And we could also say 2 pi because 2 pi is the same thing as 0. So those are the 3 angles which, oops, I'm sorry, I wrote them in the wrong place. We want to put them here, right? These are the angles z which result in sines of, sines of 0. Okay? And then the other thing is we want to figure out every possible angle in this domain which gives us a sine of 0. But in order to figure out where the smallest possible angle and the largest possible angle are, what we're going to do is we're going to take this domain, we're going to take the 0 and the pi from the domain, and we're going to put it here and here because they are going to be our lower and upper limits for the domain. And so do you notice how the x is between 0 and pi? So we need to put the limits for the domain in the first column where x is. Now, we do want to know what z value the x corresponds to. So what we're going to do is we are going to use the formula z equals 4 times x minus pi over 4 to figure out what the corresponding z value would be. So when we put 0 in here, we're going to get 0 minus pi over 4, and then we multiply minus pi over 4 times 4, we get minus pi. Okay, so that's the z value that x corresponds to. And then we're going to do the same thing here with the value pi. Pi minus pi over 4, which would be 3/4 pi, multiply that times 4, and that would give us 3 pi. So the z angle values that the limits of the domain 0 and pi correspond to are actually going to be negative pi and 3 pi. Okay, so it's a much bigger domain. Now that we know that the limits to the z domain are negative pi and 3 pi, now we can figure out what all the angles are that can have signs of 0, and we know where to stop. Okay, so like for example, if we know that 0 and pi are the two main solutions for angles that have a sign of 0, then we can find every other possible angle by adding 2 pi to 0 and pi. And in the earlier section, we noted that with this notation here, that all the solutions are going to be 0 plus 2 pi k, where k is all possible integers, and x is equal to pi plus 2 pi k, 2 pi k, where k is all possible integers. So this is like, these are like all the possible solutions if a domain is not given. And since a domain is given, what we do is we start listing out all these solutions, but when we get to the edge of this domain, or this domain, then we don't need to continue on. Okay? So like for example, 0, if we add 2 pi to that, becomes 2 pi. So actually the next value by adding 2 pi we get is 2 pi. What about the next value? If we add 2 pi to this again, we get 4 pi. But 4 pi exceeds our domain value. So we know that 4 pi is too big, so we don't need to go to 4 pi, do we? And then if we add 2 pi to pi, then we get 3 pi, and 3 pi, that is at the very edge of the domain, so 3 pi is fine. It's not only a solution, it's also the edge of the domain. We can stop right there. Now we are going to subtract from the main value 0 and pi, so we're going to take pi and we're going to subtract 2 pi, and if we subtract 2 pi from pi, we get negative pi. And we also see that negative pi is at the very edge of our domain again, so we're going to stop right there. So we don't even need to do 0 minus 2 pi, which would give us negative 2 pi. That would be way past the domain. So we have 1, 2, 3, 4, 5 solutions, and the solutions are these 5 solutions here. 1, 2, 3, 4, 5. All these solutions give us sign values of 0 when we plug them into sign. Okay, sign of negative pi is 0, sign of 0 is 0, sign of pi is 0, sign of 2 pi is 0, and sign of 3 pi is 0. And they are all within the modified domain here, right? Now let's try to find x values that correspond to this. This is the trickiest part, okay? So the way we're going to find the x values that correspond to this is we're going to use this equation. This equation is a little bit, complex, right? And it was just like x plus 2 pi or something like that, x minus pi over 4. That would be easy to, kind of do in our heads. But since this equation is quite complicated, we're going to do an inverse function. So we want an expression where x equals blah, blah, blah with z in it instead. So let's do that. We are going to divide both sides by 4 first, because we do want to solve for x. And so we have z divided by 4 equals x minus pi over 4. Then we are going to add pi over 4 to both sides to get x by itself. And then we have our completed expression. So this is our expression here. Z divided by 4 plus pi divided by 4 equals x. That is the equation we use to go from this second column to the first column. Let's try it out. We're going to put negative pi in for z, because that is our first z value, and we are going to see what we get out for x. Look what we're going to get. We're going to get 0. So the x value that corresponds to negative pi z value is 0. Let's see what the x value is that corresponds to the z value of 0. So if z is 0, it would be 0 over 4 plus pi over 4, which is just pi over 4. So the x value that corresponds to to 0 here is going to be pi over 4. So now we have two x solutions which give us a sign of 0. We have x equals 0 and x equals pi over 4. If we plug in 0 into here, we will get a angle z, which gives us 0. Okay, now let's do z equals pi. We're going to put z equals pi in here, so it would be pi over 4 plus pi over 4, which is pi over 2. So the x value that corresponds to z equals pi is pi over 2. What about 2 pi? Let's try that one. So we'll put in x equals 2 pi over 4 plus pi over 4, and that equals, let's see, 3/4 pi, right? And then we'll put that here. Not 9/4 pi, 3/4 pi. Then our last solution, z equals 3 pi. 3 pi divided by 4 plus pi over 4 equals 4/4 pi, or just pi, and that would be our last value. And so now you can see that our solutions are x equals 0, x equals pi over 4, x equals 2 pi over 2, and x equals 3/4 pi, and x equals pi, and the smallest angle and the largest angle, 0 and pi, are exactly at the beginning and the end of the domain. So we're absolutely sure that we got every single one. Okay, that's always like something that you need to worry about if you got every single angle that is in the domain that is a solution. Okay, so I hope that was slow enough, and you can see why I didn't go this slow on every single problem. Otherwise, that video would have taken 2 hours.